All right, let's talk a little bit more about complex numbers. So in the previous video, we had this diagram that these are our complex numbers, and then inside those complex numbers are the real numbers. The reason that I like writing it like this is to recognize that real numbers are actually complex numbers. Complex numbers are the biggest groups of numbers. Real numbers are complex numbers. We write complex numbers in this form here, where that imaginary piece has always been 0. So this number could be integers like -2. It could be rational numbers like 19/3. All of the numbers that you know so far have been complex numbers. We just haven't talked about this second part right here. So A is the real component, B is the imaginary component. If B is 0, we're talking about real numbers. If A is 0 and B is not, then it's called a pure imaginary number. So if you have like 4i, that's a pure imaginary number. 2 minus 4i is in our complex numbers. So imaginary numbers is the even root of a negative number. Meaning if you were to take the cube root of -8, well, -8 is -2 times itself 3 times. So you can take odd roots of negative numbers and get an output. However, up until you've learned about imaginary numbers, we would have said the square root of -8 could not be done. Well, that's because the square root of -8 is a pure imaginary number, and you haven't maybe learned about those yet. So let's look and make sure that we can write these complex numbers and identify their pieces. So if I had -3 plus 2i, the real number is -3. The imaginary component is 2i. If I had 4 minus 5i, the real component is 4. The imaginary is -5i. If I just have the number 4, then that's the real number 4 with an imaginary component of 0i. This example right here. If I had just -2i, then my real number is 0, and my imaginary piece is -2i, and again, we call this a pure imaginary